So this is another strut problem. This is an easier strut because the strut is horizontal. But in this strut problem, the strut is descending at a 20-degree angle. And then there's a cable that's 40 degrees from horizontal. So the strut is 20 degrees from horizontal. The cable is 40 degrees from horizontal, which means there's a 20-degree angle between these two guys. This is a 90-pound weight. And so I want to find this is my free body diagram. So basically I have a 90-pound weight acting downward. If you establish an X prime and a Y prime axis that are aligned up with the strut, if you sum forces in the Y prime direction just mentally, it's pretty clear that this TAC is going to be in tension. But once you get this guy in tension, then it's pretty clear that the FAB has to push on this pin. So remember, this is a free body diagram of the pin. It's not of these guys, it's the pin itself. And so FAB is going to have to push on the pin. And so this strut is in compression, this cable is in tension. So with some of our earlier examples, it's pretty clear. If I sum forces in the standard XY directions, I'm going to have two unknowns, two equations and two unknowns for TAC and FAB, and I would have to write a system of equations and use a matrix solution. But one of the reasons I'm working this problem is to show you that one of the strategies you could use as a statics student is to rotate a coordinate system, and it does two things. First of all, it gives you insight into how forces act. But secondly, it can give you an easier solution route on a given problem. So in this problem, if we rotate the coordinate systems to an X prime and a Y prime, and we sum forces in the Y prime direction, remember there's 20 degrees difference between this guy and this guy. And then there's 20 degrees difference between this, and so this axis is Y prime, and this axis is X prime. So if we sum forces in the Y prime direction, we have TA, and take that direction to be positive. This is another reason why you always assume a direction, because it just reminds you of what you're doing. So you can go TAC sine 20 minus 90 cosine 20 is equal to 0. FAB acts perpendicular to Y prime, so he does not have a component in the Y prime direction. So from this equation, you can solve directly for TAC. Is equal to 247.3 pounds. You can't get that from a Y equation, but you can get it from the Y prime equation. Once you get Y prime, then you can sum forces in the X prime direction. If you take this way to be positive, then you have the 90 sine of 20 plus FAB minus TAC cosine 20 is equal to 0. But we know TAC now. And so we can solve for FAB is equal to 201.6 pounds as drawn. And you're done. So you've solved this guy without using a matrix. You should know how to do that. A great statics student knows when to rotate a coordinate system to make a solution easier. On the other hand, if you're good with your calculator and you say, I have no problems writing matrix equations, and so I could do that. So you can do that. So, well, back to this approach here. Once I found this guy, I didn't have to sum forces in the X prime direction. I could have summed forces in just the regular X. And because I know TAC now. And so if I just would have used the regular X direction, then it wouldn't have had this 90 term in it at all. So that would have been an easier equation than using this guy. So just keep that in mind. But if I write the standard X and Y in the X direction, I've got FAB cosine 20 minus TAC cosine 40 is equal to 0. In the y direction, I've got minus sine of 20 FAB plus TAC sine of 40 minus 90 is equal to 0. Notice I always want to write these equations, and so my FAB terms are on top of one another, and my TAC terms are on top of one another. If you start mixing them up, then you're messing up your matrix. And so it's just easier if you write them this way, then you get the coefficient matrix, and it's cleaner. If you flip them, then you have to mentally flip them, and it just gets more complicated. But think about that when you're writing your equations, to always keep these terms in the same order. Once you write the x and y equations, then you can set up the coefficient matrix. This is cosine 20. This is minus cosine 40. This is minus sine 20. This is positive sine 40. You can plug that into your sine mult function on your calculator, and you get FAB is equal to 201.5. TAC is 247.2, which is basically what we got up here. So two different ways. Rotate coordinate systems. I get this. If this was a test problem and they ask you just for one of the values, just the TAC, then you can instantly rotate the coordinate system. You can write the y equation, you can get TAC, and you're done. And so there's no glory on an exam to work it a harder way. There's no extra credit for choosing the harder way. And so you should be good enough at statics to realize, okay, I can work this way, I can work it this way. Well, I really work it three ways, but this way is really easiest. And so to pick it, to work in an easy way.